Hi class, this is part 1 of section 3.5, Graphing Techniques and Transformation. We're starting with one of your PowerPoint questions to turn in through Canvas. So example 1, we're given this graph and then you have a few questions to answer about it. Okay, so energy conservation experts estimate that homeowners can save 5% to 10% on winter heating bills by programming their thermostats to 5 to 10 degrees lower while sleeping. In the graph, the temperature T in degrees Fahrenheit of a home is given as a function of time T in hours after midnight over a 24-hour period. The first part is to determine the temperature set during the daytime hours and also the temperature on the thermostat set overnight. Part B, the homeowner reprograms the thermostat to y equals f of t minus 2. Explain how this affects the temperature in the house. Graph the new function. Part C, and consider this separate, so think of this as a different homeowner, reprograms his thermostat to y equals f of the quantity t plus 1. Explain how this affects the temperature in the house. Graph the new function. Okay, so take a minute to think about that. What do you think the answers are going to be, especially for B and C? And then hopefully while we finish this video, then you can, you'll know that your answer is correct, or you can go back and adjust them. Okay, example 2. So let's start with the graph of y equals x squared. Okay, so this was one of our parent functions from the last section. So we have 5 points on the graph, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So what we want to do is graph the new function g of x, which is x squared minus 2. Okay, so I plugged in those same 5 x values and found the corresponding y values. And here the graph is shown on the same coordinate system, so we see that the graph has been moved down 2 units. All right, next we're going to graph y equals x squared plus 1. And so in green, you can now see that that same graph has been shifted up 1 unit. Okay, so again, back to our parent function y equals x squared. Now we're going to look at the function h of x, which is x minus 3 quantity squared. So this time when I picked my x values, I started with 1 and went up from there. Because I wanted, inside the parentheses, I wanted to get a negative 2. So I knew if my x value was 1, 1 minus 3 would get me to negative 2. Okay. Sometimes it's helpful to kind of start here in the middle, right? So if you plug a 3 in for x, 3 minus 3 is 0, and then take points on either side of 3. Okay, so our graph has shifted to the right 3 units. And then finally, let's say we have the function y equals x plus 2 quantity squared. This will shift the graph to the left 2 units. And maybe I have a graph on the next slide, I'm not sure, but it would start here and look like the other guys. Okay, there we go. Okay, so the first 6 are what are called rigid transformation. So the graph changes, but it keeps the exact same shape. Okay, so, and I always say horizontal changes, or let's start with vertical. Vertical changes are just what you think. So if you add c at the end of your function, the graph is going to move up. If you subtract c, the graph shifts down. Horizontal changes are the opposite. So subtracting c here inside the function, you might think that it moves to the left because you're subtracting c, but it really doesn't. It'll shift the graph to the right c units. Okay, and then similarly, if you look at f of the quantity x plus c, that's going to move it to the left. If there's a negative involved, we care if the negative is out front or if the negative is with the x. If the negative is out front, okay, so remember f of x is the same thing as y. So if that negative is out front, we're now taking the opposite of all our y values. So that would reflect the graph over the x-axis. If the negative is with the x, that's going to flip the graph or reflect it over the y-axis. Okay, so those are the rigid transformations. So again, by that I mean that the picture will stay the same. You're just moving it up, down, right, left, reflecting it. Okay, the next grouping, these are what are called non-rigid transformations. So the shape of the graph will change. Again, a vertical change is just what you think. So if we have the letter C out front, or that would be a number, right? If you had some number C out front, if this C was a number between 0 and 1, so say 1/2 or 1/3, that's going to compress your graph. Okay, it's going to vertically shrink. If you have a number out front that's bigger than 1, such as 2 or 3 or 4, that's going to vertically stretch your graph. Okay, kind of make it taller. If the C is with the X, if it's inside, this is going to be a horizontal change, but this is the opposite. So if we multiply by 2 inside, it really compresses the graph. And if you multiply it by 1/2, it's going to horizontally stretch the graph. Okay, so these are the parent functions that we talked about in the last section, all except for this last one. We don't need 1 over x squared. That one we're not talking about just yet. Okay, and then here's some examples. So in blue is our parent function, y equals the absolute value of x. If x plus 1 is inside the absolute value bars, that's going to be a horizontal change. So it's the opposite. Move it to the left 1 unit. And then now this -3 is outside, so it's a vertical change. It goes down 3 units. Okay, so let's say we're going to graph these functions. Okay, there's a bunch of them, and then there's one at the end for you guys to do. All right, so describe the transformation. So I'm looking for words where you tell me what's happening with the graph. Okay, so we know that we're starting with the absolute value function, so I'll just write that down as well. And then remember, this is our v function. The two transformations are, so I have this -3 that's with the x, so that's going to be a horizontal change, but it's always the opposite. So subtracting 3 is really going to move the graph to the right 3 units. And then the -5 is going to send the graph down 5 units. Okay, so I'm going to kind of start here at the origin and go to the right 3 and down 5. And otherwise the graph stays the same, right? It's what's called a rigid transformation. Oh, label 3 points on the graph. Since I don't really have a ton of room on the graph, so I'm just going to put those 3 points over here in a t-table. Okay, so that's fine. I'm going to put 3 here in the middle because that's a point that I really care about, right? That's this low point over here. Okay, so the x value was 3 and the y value is -5. I'll then just pick a point on either side of 3. So let's do 2 and 4. And we can see from the graph that we're at the y value is -4. You could always check it by plugging it in. So 2 minus 3 is -1. The absolute value of -1 is +1. And then 1 minus 5 is -4. Okay, so there's the graph drawn on Desmos. Okay, next, f of x is x plus 2 quantity cubed minus 3. So for transformations, well, first of all, parent function, we're looking at x cubed. Okay, so that's this guy. Plus 2, remember the opposite, so we're going to move to the left 2 units, and again, still down, we're going down 3. Okay, good. So starting at the origin, I'm going to go to the left 2 and down 1, 2, 3, put my point. So -2, -3 is my ordered pair. I'll also look at a -3 and -1 for a number to the left and to the right of this. Okay, so if I go to the left one, I know I should be down 1. Okay, so I know that those are points because I know the points over here on my parent function. Okay, so 0, 0, 1, 1, and -1, -1. So I'm kind of taking those 3 points and moving them. Okay, if you want -3, -4, -2. If you want more points, that's fine. But remember, the next point over here on the graph was 2, 8 on our parent function. So the graph increases pretty quickly, right, once we get beyond kind of this section between -1 and 1 on our parent function. Okay, good. So there's a rough sketch of our graph. I'll put some values here as well. Okay, good. And there's the graph drawn on Desmos. Part C, our function is f of x is 3 times the square root of negative x plus 1. So our parent function is the square root function. I'm going to rewrite our function. We have a negative under the radical, but then we're still adding 1 here. So I'm going to write this as the opposite of x minus 1. This step is optional. I think it's sometimes helpful when you're graphing by transformation, but as long as you're giving me transformations, you're describing the transformations and they make sense, and then your final graph is correct, you're good. Okay, so no matter whether you rewrite the expression under the radical or not, your transformations are still going to be vertical stretched by 3. You're still going to reflect it about the y-axis. Okay, and then now this part is going to be different. So since I factored out that negative, I have x minus 1, so I'm going to say that's a shift to the right 1 unit. If you didn't factor out the negative, you might tell me that you shifted to the left 1 unit, okay? And the reason why they're both okay is because it depends on the order in which you do these two things. If I start with the radical, well, so I think maybe it's easiest just to then go to your table. Okay, so we want to find a key value. I want to know what to plug in to get to kind of my starting point of the square root function, right? So the square root function starts at the origin and goes into the first quadrant. So the parent function starts at 0, 0. I want to know where that corresponding point is on my graph. Okay, so no matter if you rewrite it or not, hopefully you'll see that if you plug in an x value of 1, you'll have 1 minus 1, which is 0. The opposite of 0 is 0. The square root of 0 is 0. Times 3, we're still at 0. Okay, so again, you should come up with this 1, 0, regardless of whether you rewrote the function or not. Okay, so 1, 0 over here. But now, since, again, no matter which way you're looking at it, we can plug in numbers that are smaller than 1, because I have to make sure that I eventually have a positive number under the radical. Okay, so let's try 0. So if I have 0 minus 1, that's going to be negative 1. Multiplied by a negative, so now we're at positive 1. The square root of 1 is 1. Multiplied by 3, so we're at 3. Okay, so far those are the 2 points that I have. And now for my third point, I'm going to do a little bit of work over here in the margin. Again, it doesn't matter which expression you go to, so I'll just look at negative x plus 1. So this is the value under the radical. So I want it to be a perfect square. So I've already done the square root of 0 and the square root of 1. I would next like to take the square root of 4. Okay, so work this out. I'll get that negative x is equal to 3. So x is going to equal negative 3. That's the next x value I want to use. So again, it doesn't matter which expression you use, you'll get still negative 3. So negative 3 minus 1 is negative 4. The opposite is positive 4. The square root of 4 is 2 times 3, so we're at 6. So negative 3 is here, and then up 1, 2, 3, 4, 5, 6. Okay, good. So those are my 3 points, and then I'm going to sketch the graph. Okay, and make it kind of look like the square root function. Okay, good. So again, things that you need to have on your graph. You're describing the transformation. Okay, rewriting it is optional. I do think it's helpful sometimes if you have a negative with the x, but then you're still adding or subtracting. Okay, I moved my graph to, so I guess I did it in the order I have listed here. So when you stretch it by 3 doesn't actually matter, right? Just at some point you have to stretch it by 3. Reflect it over the y-axis. I would have done that second, and then I move it to the right 1 unit. if you didn't take out the negative, you may have said here, shifted to the left 1 unit. That simply means that if you take your square root function and go to the left 1 unit, it would look like that. And then you reflect it about the y-axis next, okay, to still lead to this final graph that we have over here. Okay, so since the order sometimes makes a difference, you just need to be careful, make your best guess, and then always check your answer as well. Okay, so here's the graph on Desmos. So we see we're at 1, 0, 0, 3, negative 3, 6. Okay, part D, now we have negative 1/2 times the quantity x plus 1 squared plus 2. All right, so this is our parabola. So the base function is y equals x squared. And we're going to be doing more of these later on. We have a whole section just on parabolas. Okay, we have 4 transformations actually. Okay, so the negative out front is going to reflect it about the x-axis this time. The 1/2, remember this is also a vertical change, so it's just what you think. So since we're multiplying by 1/2, this is going to be a vertical compression. The plus 1 that's with the x, this is a horizontal change, so it's the opposite. Adding 1 really moves it to the left 1 unit. And then adding 2 at the end, we're going to shift the graph up 2 units. Okay, x and y. So a key point I want to look at is what happens when x is negative 1. Okay, so we know this for a couple reasons. First of all, we shifted to the left 1 unit. Okay, so instead of being at the origin, we're now going to be at negative 1. Okay, also if I just look right here, negative 1 plus 1 is 0, and so I know that's going to be a key point. So 0 squared is 0 times negative 1/2, still 0, and then you're up 2. So negative 1, 2 is a point on our graph. Okay, the negative out front means it's been reflected about the x-axis. Think of it now as your parabola opening down. Okay, so normally it's a U-shape opening up. With that negative out front, it's going to open down. Okay, also normally we would be at these 2 points here, so 0, 1 and negative 2, 1, because normally from that, it's called the vertex, so from the lower point on your parabola, normally you go over 1 unit in either direction. So negative 1, 1 and positive 1, 1 are the points on the graph. So normally, same thing, you'd go 1 unit in either direction and down 1 since we've reflected it. However, since this has been compressed, those 2 points are going to be closer to, again, what's called the vertex. So they're going to be up here. Okay, what might be easier is instead of using those 2 points, so instead of going 1 unit on either side, let's go 2 units on either side. Okay, so from negative 1, let's go 2 units to the left, so we'll be at negative 3, and then 2 units to the right will be at positive 1. Okay, and so again, this is because I know it's been vertically compressed by 1/2, so instead of just going 1 unit on either side, I'm going to go 2 units because then I know the answer will be divisible by 2. Okay, all right, and I'm going to erase those because those are not on this curve. All right, so let's plug in a negative 3. So negative 3 plus 1 is negative 2. Square it, we're at 4. 4 times negative 1/2 is negative 2 plus 2 is 0. So negative 3, 0. And so that means 1, 0 should also be the point. Okay, parabolas are symmetric about the vertex or this vertical line that goes through the origin. Okay, and then just real quick, normally on your graph of the parabola, if you're over 2 units, you'd be up 4. So when I say over 2 units, I'm talking about from the vertex, or in this case, in our parent function from 0, 0. So here I go over 2 units, so I happen to go to the right. So instead of going 4 units, I'm only going 2 units. Okay, and again, that's because of that 1/2. Okay, sketch it. And there's the graph of our function. Okay, so when I personally graph things by transformation, I use the transformations to get an idea of what the graph is going to look like, but then I do kind of switch over to coordinates. The book sometimes will take an ordered pair such as like 2, 4, and then they'll move it all around, right? So you move this coordinate to the left and up and reflect it and do all those things. I prefer to just to list the transformation so I know what's going to happen, so I have a picture in my mind of what the final graph should look like, but then I switch over to plotting points and try to pick points that work out nicely, right? So that's why, again, we use -3 and +1 because those values worked out nicely and for the y value. Okay, so you're certainly allowed to do a kind of a combination like that as well. I want to see your list, so you have to describe the transformations, okay? But then when it comes to plotting the graph, obviously you're doing that however you choose. Okay, and then here's the graph on Desmos. All right, this one is for you to complete and turn in through Canvas. So part E, f of x is the fourth root, is 4 times the third root of the quantity x plus 2. Okay, so the x plus 2 is all under the radical. All right, so that makes a difference. X plus 2 is under the third root, and then we multiply by 4. So describe the transformations, and there are 2 transformations. Okay, you probably want to state the parent function first, describe the 2 transformations, and then sketch your graph. Label at least 3 points on the graph or on a t-table beside the graph. All right, good luck. Let me know if you have any questions.